Good afternoon. We are Group 8 and we'll be presenting on input and output in computer architecture. This presentation will introduce us to the concept of inputs or outputs in computer systems. While we are focusing on the importance of it, we'll also talk about the functions and give some examples of these input and output devices. Okay. Understanding input or outputs. First of all, we have to know the definition for input and output, and it basically refers to the communication between a computer system and its environment. In a setting, we can say input or output is like the brain, where information gets in and the information comes out. The process of information getting in is termed as the input, and the process of information coming out is termed as the output. Moving on to the importance of input and output. One, it's fundamental to computer operations, and it also enables user interaction. It is used for storing data. And also, moving on to the basic input or output operations. Typically, input or output operations involve reading data from input devices and writing data to output devices. Moving on to the next slide. And here we'll be talking about the examples of input and output devices and giving their functions. So under input devices, we have keyboards, which allow test and command inputs. Under input devices, again, we also have scanners. Scanners converts physical documents into digital formats. And under output devices, we have monitors, we have printers, we also have speakers. For printers, it produces hard copies of digital documents, and for monitors, display visual output for user viewing. Thank you. This is the end of my presentation. My colleague will continue.
Input and output models interfaces. Bridging devices to the system. Bridging devices to the system as input and output models act as intermediaries between the CPU and peripheral devices, managing data transfer and control signals. They handle device-specific protocols and data formats. Interfaces. Common interfaces like USB, SATA, and PCIe. These interfaces define the physical and electrical connections, as well as the communication protocols between the input and output model and the device. Device drivers. Device drivers are software components that enable the operating system to communicate with specific input and output devices. They translate generic input and output requests into device-specific commands. Properly designed input and output models and interfaces are essential for ensuring compatibility and efficient data transfer between diverse devices and the computer system. So I will give it next to my colleague to present.
So I'll be taking the program input and output, which is basically the CPU control data transfer. So in the programmed input and output, the CPU directly manages data transfer between memory and input and output devices. It issues commands to the input and output device and continuously waits until the device is ready to send or receive data. This is how it works. The CPU initiates the data transfer, and then it waits for the input and output device to be ready. Then once it is ready, the data is being transferred. And here are some drawbacks concerned about the program input and output. One, the CPU is heavily involved, leading to inefficiency. Two, the CPU spends time waiting for slower input and output devices. And three, it's limited to low-speed data transfer, meaning it's not suitable for high-speed data transfer. So in all, the programmed input and output is simple to implement, but is generally inefficient for high-performance system due to the CPU's direct involvement. And for the interrupt-driven I/O, which is responding to the device needs. So first we'll be taking the interrupt request. So an input and output device sends an interrupt signal to the CPU when it requires attention, such as when data is ready or an error occurs. Then when it gets to the CPU responds, but the CPU suspends its current tasks and executes an interpret in, in and executes an interrupt handler routine to service the input and output device. Then data is being transferred. So the interrupt handler performs the necessary data transfer or controls operations before returning control to the interrupted program. So the interrupt-driven I/O allows the CPU to perform other tasks while waiting for input and output devices, improving system efficiency compared to the programmed input and output. Please, my colleague will take the next slide.
Direct memory access, that's the DMA, bypassing the CPU for speed. So the direct memory access controller, it allows input and output devices to transfer data directly to or from memory without CPU intervention. A DMA controller manages the data transfer, freeing up the CPU for other tasks. So the DMA actually manages the data transfer. So the transfer from one place to another, it manages it so that it doesn't take much space in order for the CPU to freely operate. Benefits of the DMA: significantly reduce CPU overhead, enable high-speed data transfer, improves overall system performance. The DMA is essential for high-performance input and output operation, such as video streaming and disk access, where large amounts of data needs to be transferred quickly. Please, next. Inputs and output channels and processes. Advanced data management. The input and output channel. Specialized hardware components that handles the input and output operation independently of the CPU. The input and output processor. More sophisticated than channels, with their own instruction sets and memory, enabling complex input and output tasks. So the processor is sophisticated than the channels. Therefore, it has its own instruction sets and memory. Thank you. Benefits: it reduces CPU load, improved system throughput, and supports for advanced input and output function. I/O channels and processors are used in large systems to offload input and output tasks from the CPU. Further enhances performance. Thank you. The next person will continue.
Performance consideration and latency, throughput and bottlenecks. So we are taking the latency. The delay between an input and output request and its completion. that is minimizing latency, is crucial for responsive systems. And the throughput, the rate at which data can be transferred, that is minimizing throughput, is essential for high performance applications. Also, bottlenecks, components that limit the input and output performance. That is, identifying and addressing bottlenecks is key to optimizing system efficiency. So the input and output performance is critical for overall system responsiveness and its efficiency. Optimizing input and output operations involves minimizing latency, maximizing throughput, and identifying or addressing bottlenecks. So finally, we're taking the conclusion. Output is fundamental to computer system operations, and various input and output methods offer different performance characteristics. So understanding the input and output concept and techniques is crucial for computer architects and system designers to build high performances, responsive systems that meet the demands of modern applications. Future research will focus on improving efficiency to show at speed and efficiency. Thank you very much. So we bring our meeting to an end.